Welcome back to the Building HVAC Science podcast. It's our goal at Building HVAC Science to create better, more knowledgeable HVAC and building performance technicians by helping the two professions better understand each other, with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. I've been doing this gig, HVACR and building performance, working in these markets for over 30 years, and I meet some very interesting people. One of those is my guest today, Alex DeGagne. Alex is CEO and owner of MINOTAIR, a manufacturing company currently based in Gatineau in southwestern Quebec, Canada. His main product is the PentaCare V12, a compact, ultra-efficient air exchanger that incorporates a HEPA filter and uses self-contained heat pump to control ventilation, temperature, and humidity. In the words they use on their website, the PentaCare Series is a product using cutting-edge technology to take care of 5 things: HVAC-D, heating, ventilation, air filtration, cooling, and dehumidification. It's like 4 machines in one, an active heat and energy recovery ventilator with the highest SRE efficiency, certified by HVI for the best comfort. It's also a ducted air source heat pump. Third, it's a dehumidifier. And fourth, it's a HEPA MERV 15 medical-grade air filter device, which can help greatly during wildfire smoke episodes and just in general with particulate arrestants. Alex speaks to us today about science, especially building science, home construction, and indoor air quality, as well as the practical aspects of manufacturing and distributing such an innovative product. There's a ton of info in the show notes, including links to Alex's LinkedIn profile, links to the Minotaur homepage, information they provide on ventilation, where to buy, even the brochure and instruction manual, as well as an overview by the Department of Energy about the ASHRAE 62.2 specification, in case you're not familiar with that. Okay, let's get on to the interview with Alex DeGagne and learn about the science of air leading to healthier indoors. So I met this gentleman, Alex DeGagne. I hope I got that right. DeGagne. Yep. Mm-hmm. I think I met you in person at a indoor air quality conference in Maine. We were connected on LinkedIn before that. Alex, why don't you introduce yourself to the audience?
Yes, thank you, Bill. So Alex DeGagne is my name, south of the border, because I'm from the beautiful province of Quebec, just beside Vermont in the state of New York. So, and up there, my name is Alexandre DeGagne, but let's keep it simple with Alex DeGagne. So I do work for a company called Minotair. And Minotair is a HVAC manufacturer, and I'm actually the newly appointed CEO and chief of sales. And on top of being the new sole owner of the company, I've been with Minotaur for 7 years and a half now, and the company is 10 years old. So by trade, I am a jack of all trades in the high-tech building technologies. My father was a builder. Back in '65, he did something very fantastic. Even back then, he was thinking of reusing products. Like in our living room, instead of having gyprock boards, he did put some, those grayish barn planks. So he put that there, and behind them, he has put some aluminum foil to reflect the heat in the '65. So I'm luckily the son of that innovative builder, and now we try to be as innovative as possible with our company. More on that later with your questions, I guess.
Sure. So first off, why the name Minotaur? You see the word air in it. I see Min. I think of Minotaur. How does this all come together?
So Carl Audet, who was until recently my business partner and still works for us at Minotaur as our lead engineer, 10 years ago, when he was at the Federal Office Bureau to get the comparison papers, he was told that instead of getting a name of a company with numbers, he was told that you could put a name to it instead of having 72, 55, 37 Canada Inc., because we're from Canada. So he had 5 minutes to find a name. Back then, in his mind, the product was half an air source heat pump and half an HRV ERV. So 2 in 1. Therefore, Minotaur, where it's half man, half bull. So I said, Minotaur, Minotair. So this is how the company name was found within 5 minutes over 10 years ago. Actually, April 2013 to be precise, because we did celebrate 10 years of existence. Officially 10 years, last April of this year. Now, in this fall, we should do some very interesting celebrations with that, especially that we just moved to a much larger facility, a state-of-the-art facility now, to produce more machines.
So let's talk a little bit about the machine. You gave us the introduction, half HVAC, half ERV. How does that all work together?
We call our very interesting machines all-in-one HVAC-D units, D standing for dehumidification. So in reality, imagine you in your head, imagine an HRV with top ports. So a white rectangular box where you have 40 inches of length, 80 inches of depth, and 16 inches and a half of height. And you've got 4 ports on the top. And you could act just like an HRV and ERV to do fresh air. But we don't only do fresh air with that fantastic machine. We also do 5 things. Therefore, the name PentaCare Series, because those machines take care of 5 things, which is fresh air, with the highest heat recovery numbers ever certified and seen by the HVI. And then we do heating and cooling because our machines are singly packaged heat pumps with no outdoor units. We'll come back to that later. They also do tremendous dehumidification work because from day one, those machines were designed to do so. And finally, we do a very useful thing, which is HEPA MERV 15 air filtration with a combination of a MERV 8 and a MERV 15 filter to make sure that we capture about 90% of the wildfire smoke particles. So again, it is a single box where you have all the components of a ducted heat pump. So it's not like a mini split where you would have outside a box where you would have a coil and a compressor working with the outside air. So what we do is the fact that that coil is within that single box. And so interesting enough, we still work with that same outdoor air. It's just that we use the conduits, the 2 ducts connecting to the outdoor to get that outdoor air, bring it inside the unit, crossing that coil, and then the air gets back outside using the second that gets the stale air out, usually when the machine works as a fresh air appliance or HRV ERV mode. So the machine works, those machines, they do work in alternates between, they work either as a fresh air appliance or they work as an air source heat pump. But the good news is every 30 minutes, you have the exact same amount of fresh air than a continuous ventilation equipment, which is good because it is permitted by ASHRAE 62.2 that states you've got 3 hours to bring in the exact same amount of fresh air in a non-continuous way compared to a continuous ventilation, which is fine. The good news is we are 6 times compliant with that request from ASHRAE 62.2. Not only we're 6 times compliant, but we're doing every half hour a better job than any HRV ERV you can think out there. And by the way, I used to work for Fantech System Air for 3 years. Still have very good colleagues there and friends. And very proud to say that I worked for System Air for 3 years. The thing is, what we have as a technology is kind of a 21st century technology for heat recuperation for residential ventilation. Let me explain here. So the thing is, because our machines, they need to work faster to bring in every half hour the same amount of fresh air as a continuous ventilation would do as an HRV ERV. Once that we do that, so let's say that we have, like I said, every half hour, there's always a portion of minutes where the machines will work to bring fresh air in, but faster. And then the rest of that half hour minutes, the machine will go in recirculation to work as an air source heat pump. And cleverly using the same ductwork that we're using for the fresh air. Okay, so that brings a lot of advantages. Number one, every half hour, yes, we bring the same amount of fresh air in. That we do a first pass of filtration with the MERV 8 and the MERV 15 filter. But then when the machine goes in recirculation to work as a heat pump, we do continue to scrub, to filter, to clean that fresh air we just got in. So meaning that every half hour, we bring in the exact same amount, same volume of fresh air as any HRV ERV out there. Plus, we do clean it even more. And plus, we're removing moisture because our machines, being heat pump based, they are able to remove a lot of moisture, especially that our machines are tweaked to do that. We are removing 3 to 4 times more moisture than equivalent size in our ASOS heat pump. Why? Because from day one, our machines were designed to do so. And number two, we're moving more air. So physically, it's feasible that we are removing more moisture out of the air. So at the end of the day, and strictly for the fresh air and the air quality portion of it, we do a fantastic job that actually no one does exactly like the way we're doing with the levels of efficiency we're doing. And among other things, levels of efficiency, where we are extremely proud that for the last 4 years, we have the highest efficiency numbers from the HVI in terms of heat recuperation for the sensible recovery efficiency. So being at 116%. And before someone says, hey, that doesn't make sense, how can you be above 116%? Let me explain something. So HVI certifies the performance numbers, okay? But where do they come from? Well, There's only one lab for now in North America, a third-party lab, testing residential-sized HRVs and ERVs. It is in Mississauga, which is part of the Toronto greater area up in Ontario, Canada. And for the last 30-something years, they've been testing all the HRVs and ERVs from the major serious HRV and ERV manufacturers. So 20 years ago, that's the standard of any realty is CSA 439, and CSA is the Canadian equivalent of UL. By the way, both organizations do work together. So CSA 439 that was developed in 1985 was modified about 20 years ago to include active heat recovery machines like ours, meaning using components of heat pumps to capture heat. Because we capture heat, we capture not only the sensible heat, but also the latent heat contained in the air. So meaning that standard can test machines like ours. And we still, to this time, the only active heat recovery fresh air machine to be tested with success under CSR 439 and being certified by the HVI. So where that 116% comes from, it's easy. Once that you read the standard CSA 439, you are able to see that in reality, the sensible recovery efficiency, the SRE, which is the benchmark to compare HRVs and ERVs in terms of efficiency, is how much heat energy can you capture compared to how much electrical energy, compressor included, in our case, are you using. So yes, in our case, we're using more heat, and we're using somehow more electricity than just a spare fans in an HRV or an ERV. But in sheer efficiency, we're bringing in way more heat. To give you an idea, in our case at 116%, because then again, it's a ratio. Okay, so 1.16, that goes to 116%. So the thing is, in our case, we capture the heat from the stale air like anybody else, but contrary of anybody else, we capture the heat from the moisture. And also, remember, it's one single box with all the components of a heat pump inside. So we have the compressor on the left side of the unit. And the work of the compressor gives us about 1,000 BTUs of heat that we're using. Because we are from Canada, we are definitely a heating predominant sector. We have decided to put that heat in the fresh air stream to take advantage of that. So we don't have one heat source to recuperate, but 3 heat sources. Meaning that one of the standardized tests goes like this, Bill. When it is 32 Fahrenheit outdoor and 72 Fahrenheit indoor, and if you move 100 CFM, the fresh air exiting the unit before entering in the house or the apartment is at 102 Fahrenheit. Yes, you heard that well, ladies and gentlemen. Even if it's 32 Fahrenheit outdoor and 72 Fahrenheit indoor, the measured fresh air exiting the supply part of our units is 102 Fahrenheit. This is why that we have a current sensible efficiency of 178%. Not indicated by HVI, but still part of the lab report from Exoval Element, that third-party lab that actually sent those reports to HVI directly. So like this, manufacturers cannot temper the numbers, which is logical. So an AAC of 178%, meaning that when it's 32 Fahrenheit outdoor and 72 indoor in your house, when you move 100 CFM, not only we bring fresh air in, but we help heating the place at the same time, meaning that it's going to be way more comfortable, than any machine you can think of. Because the second best machine out there will be, instead of bringing fresh air in at 102 Fahrenheit, it's going to be like 69, 70, meaning that if it's 72 indoor, it's going to make the place a bit colder. So strictly on the fresh air recuperation sector, we are miles ahead of anybody else. And at the end of the day, efficiency-wise, in terms of the electrical consumption of our units, when you compare all the things those units do, we are extremely efficient, because a common mistake is to compare us strictly to a regular HRV, ERV, and with a ductless split air source heat pump. But the quantity of moisture removed with those units, to do that, the same amount of work, I should say, you would need a standalone dehumidifier. Either one with a bucket or a great machine like a Santa Fe or something like that. By the way, hello, Nikki Kruger, my colleague of the industry that I saw a few weeks ago with her husband at the Building Science Summer Camp, organized by Betsy Pettit and Joe Stiebrick, as we know. Anyhow, so you would need a standalone dehumidifier. And at the end of the day, also, we are doing a medical-grade air filtration with a combination of MERV 8 and HEPA MERV 15. And why am I allowed to say that I'm talking about medical-grade air filtration here? It's because ASHRAE 170, which is the ASHRAE standard for healthcare facilities, states that at MERV 14 and above, it is considered medical grade. So consider all the things we do, the fresh air with the highest heat recovery numbers certified by HVI, that heating, that cooling, that dehumidification, and that high efficiency air filtration. We are extremely efficient in that regard with one single unit.
Thank you for the explanation. Back on the applications, because this device is a very smart device, it must have a target application or set of applications where it works the best. Can you tell us about those?
Actually, there are two main usages for those machines. The company saw the light over 10 years ago because up here in Quebec, where it's code for over 25 years to have HRVs in new construction, a lot of people in the summertime, they are turning off their HRVs. And even if it was an ARV, they would turn it off. Why? Because it still brings a lot of hot and muggy air from outside. So the problem is, you just bought a brand new house, you have an HRV or an ARV inside of it, and you decide to turn it off for months during the summer season. Not a good idea because you're living technically, especially up here, the new homes are pretty much airtight. We're not talking of passive house levels, but still 2.5, 3.5 air exchange. And people are turning off their machines. And they're not necessarily opening their windows to get more fresh air because, hey, the air is hot and muggy, especially southern part of Quebec, like Montreal, where I live. It's like Boston. It's really hot and muggy, especially in the last 10 years. So Carl saw the opportunity then said, okay, I guess there's something different we should do. Carl by training is an engineer. He was also an officer with the Canadian Armed Forces, with the Air Force, in charge of the telecommunication protections. And the guy is a very good handy guy. So he learned about heat pumps, and then he saw that, okay, those heat pumps are pretty good to capture heat, even better than those passive core HRVs and ERVs. And also a heat pump, when tweaked correctly, is a fantastic dehumidification device. So the idea at first was to have a super HRV dehumidifier to get the best indoor quality for a whole house. This is how the company started. When I've met Carl at fall of 2015, it was obvious for me that that product had a fantastic future in multifamily buildings as an all-in-one system. Contrary of Carl, I knew about passive house, and I told myself that machine has the potential to be the product of reference, especially in multifamily applications where you're going to put one machine per apartment. And that's great because it appears that in July 2019, Dr. Joe Stiebrek wrote an article in the ASHRAE Journal in July stating that when you apply comfortabilization principles within a building where you make sure that the apartments are airtight between each other, not to be able to smell the cooking of your neighbors, and with COVID, not breathing the same air as your neighbors, Dr. Stiebrek said, we can apply that same principle to mechanical systems. And according to him, the future of HVAC systems in multifamily buildings is decentralized/autonomous systems, one piece of equipment per apartment. And this is exactly what we've been doing for the last 10 years. So to have Joe Stiebrek wrote an article on that, it was amazing for us to say, wow, okay, so we're not the only ones seeing that future. Okay. And more people are seeing that future too. When your loads are low, you don't need as much as a big equipment. And this is exactly where we hit the target, right? In the sense where we have machines fitting the bill perfectly and saving time because we don't have to need miles of refrigerant line where you could have leaks. The machines are prepackaged and that's tested at the factory. You don't have miles of ducts through crossing floors. You don't have to take huge space on a rooftop with a commercial, either VRF system or DOAS or ERV, whatsoever. And the list of advantages goes on and on and on. So right now, the core of our business is actually the pioneer and North American leader of that all-in-one HVAC-D unit for multifamily buildings.
You mentioned before the word appliance fits very well.
Yeah, I said fresh air appliance because when we talk to non-technical people outside our industry, if I say fresh air appliance, people, they will catch what's going on. Okay. So an HRV and also an ERV, they are fresh air appliances, reality. And we are the same. It's just that we do the same job as an HRV. We do a similar job as an ERV in terms of dehumidification, but in a real effective way because ERVs are not dehumidifiers. Some people think that they are, they don't. That they only transfer moisture from one stream to other when the other stream is drier. But anyhow, so we have a common understanding in the HVAC industry where ERVs are not dehumidifiers. They are great machines, but they are not dehumidifiers.
And it's plug-in, correct? 120 volts?
It's on 120 volt, 15 amp on a dedicated circuit. Pretty simple, straightforward. What's interesting also is those machines are made to be swapped within an hour by two regular maintenance personnel, not necessarily by HVAC techs. All the projects we're doing, they have on the premises backup units. which is a first in a sense where customers, they love that concept where, especially Tim McDonald, one of our first customers in multifamily buildings in North America, using 28 machines in Philadelphia in his fantastic front flats building by his company Onion Flats. So having a backup unit on the premises, well, customers are telling me it's not rare that Christmas time something happens. So at least to have a few units on the premises where units can be swapped within an hour, it gives peace of mind not only to the building managers, building owners, but also for tenants. So that is cleverly done. Also, those units, because they are made of aluminum enclosure and stainless steel hardware, which is more money upfront, the good news is we have announced about 6 months ago, Bill, a refurbishment program. We believe that Minotair is the first HVAC manufacturer here in North America that has announced a refurbishment program that in 10, 15, 20 years from now, if and only if we're still able to get those wear and tear parts, we'll gladly refurbish those units. Why? Because you and I, we have flown aboard airplanes made of what? Aluminum, stainless steel, copper. And those airplanes are 30, 40, 50 years old and still have the right to fly. And why? Because they are maintained and we change the wear and tear parts. So we need to be more sustainable. And this is one very clear way that us as a small but fast-paced growing HVAC manufacturer are bringing to the table. Another plus that we bring to the table to our customers.
So going back a little bit in these applications like Tim McDonald's and the Onion Flats, are these the only unit in an apartment? There's no other heating, cooling?
So because so far our machines are not cold climate heat pumps, and we never hided that fact, our machines do still work around 12 Fahrenheit and still producing about 3,000 BTUs. Each time our units are to be used as the main heating system in place, it is mandatory to use an electric duct heater that we sell also. Fully variable in intensity, fully controlled by the PentaCare unit itself, meaning that the homeowner or the tenant will only have to interact with one wall-mounted controller that looks like a thermostat ISIL, and that's it. So it's seamless. But the upcoming version of our products will bring whole climate version. We are working on that as we speak. But that's pretty much it. So we have some customers who are only using our machines because they don't, especially if they are in a temperate climate. But we always say, even if you are, in Pacific Northwest where you don't have harsh winters, or California or something like that, because of climate changes that we're witnessing and experimenting in the last 10 years, there are places where you would never imagine that you would need some solid heating capacities. Last year in Texas, they had snow in cold days. So to have for about $500 a 5,000 watt electric duct heater, fully variable in intensity, is a cheap insurance to make sure that you're going to have heating. But let me add one last thing regarding that. Our customers, they are okay with the fact to have an electric duct heater as a backup for two reasons. One, when our machines are to be used, it's because they are used in high performance / passive house multifamily buildings, meaning that the heat loads will be quite low. And also the heat losses will be quite slow. So at the end of the day, those electric duct heaters will not run a lot. And when doing so, they will not use a lot of electricity. But like I said, we're coming with a cold climate version of our products in the upcoming 12, 18 months, hopefully, something like that.
And with the construction from aluminum, stainless steel, and a lot of the volume, I'm sure, is just air channels inside, it's probably not very heavy, is it?
110 pounds. So you need two persons to hang the unit on specialized straps that are quick to install. And also they do help to level the units because they have buckles. There's a lot of cleverness from our company, surprising.
I'll include links to the spec sheet, the manual, and the manual explains all the airflow patterns that you're hearing on this podcast now, but I think seeing them physically on paper will help you understand that. What do you think is the opportunity for this going forward? I mean, it has ECMs in it, a couple of ECM motors.
A pair of cement motors by HVAC, which means that they are self-adjusting, self-balancing, meaning that when you'll have dirtier filters, the fans will ramp up in speed, will ramp up in RPM to make sure that you will always get the right amount of CFM required in the apartment or in the house, because we have something extremely clever. Instead of having a cheaper solid-state electronic card as a controller, we have a commercial-grade PLC microcomputer made by Carel. Carel is widely used right here in North America, especially in the States, for commercial rooftop equipments, HVAC equipments. And that that computer gives us the opportunity to change the brain of the machine with a simple USB key And it takes like between 3 and 4 months, and you have a new version of the brain of the system. So we are able to, over the years, make better the machines and sometimes bring some features. And right now, for multifamily building, we are working with a fantastic company, a BMS company, and we're about to bring a BMS system for our machines where even that process to up to a new software update could be done remotely with that BMS system instead of having someone going in 200 apartments with a USB key while changing the filters. We're bringing something very interesting in the upcoming months with a BMS in conjunction with a specialized company working with us for our machines.
Did I also see that there's a networking capability for monitoring and control?
Yeah, BMS is exactly that. That's a building management system. BMS, it brings the possibility to remotely monitor and even control units in a multifamily project. So that's the whole point. So like this, you're able to see if one unit needs help, if a unit needs to have its filter change. So we are quite eager to bring that to our customers because they will be able to retrofit their systems with that upcoming BMS.
What type of sensors are inside the system?
We measure temperature and moisture. And we're looking at also the possibility to, in a brief near future, to measure CO2 and VOCs to make sure that we'll be able to boost ventilation if needed.
Got it. So now 25% of the listeners are interested. I'm projecting in the future.
Well, that's good.
So
I'm happy to hear that.
I've got the website link. I looked at your website. You have about 12 dealers in the USA.
Yeah, surprisingly for now, we had a slow starting because we are a small HVAC boutique manufacturer, but we doubled the sales of our company in the last 3 years in a row. We just moved to a much larger facility where we are about to bring in our production lines some optimization processes, robotization processes to be able to offer more machines because we're not able to keep machines on the shelves. They are pre-sold months in advance. And this is why I'm moving to that new facility that we just did this at the end of this spring. We are able to cope with the stronger and stronger demand. Actually, we are planning to have a first U.S. factory for us probably by 2026, and probably in Syracuse, New York. And why Syracuse, New York? For two good reasons. Number one, it's like 4-hour drive south of where we are right now. We are just beside Ottawa, but on the Quebec side in a town called Gatineau. And Syracuse, New York is just like 4-hour drive south. And the reason number two is because Syracuse is the birthplace of Carrier. And Carrier is the inventor of the refrigeration process. So that would be interesting for us to be there. So yeah, it could be some other place, but for now we're aiming to be there in about 3 years from now. We want to fine tune those new processes that we are putting in place right now in our new factory. And the ones that we're going to have a manufacturing recipe we're happy with, we will be able to duplicate that. Syracuse, New York. We have demands also in South America. I've got some business partners who would like for us to open a factory in Monterrey, Mexico, same city where Tesla did put one of their most recent factories. So yeah, and also some demand from Australia, New Zealand, and Europe. So maybe a factory in Eastern Europe, maybe some next 4 or 5 years. A lot of activities for us, a lot of demand, a lot of positive things for us, keeping us extremely busy, actually.
Of course. Very good. What's the typical airflow range that it'll produce?
So in terms of total airflow, the units we're going to work on a regular basis near 250 CFM. So you'll need an 8-inch ductwork instead of 6-inch to manage that capacity. Because don't forget, the machines, they work in alternate between, we work as an HRV, ERV to provide fresh air, but a higher CFM rate. And then we go back in recirculation to work as a ducted heat pump. So duct design must be tweaked for 250 CFM. Their ductwork must be prepared for 250 CFM.
Very good.
And fresh air range in reality, if we strictly talk in terms of fresh air, we can provide up to 120, 130, 40 CFM of fresh air without a problem, and still being able to provide some cooling and heating and dehumidification capacities
At the same time.
at the same time. Yeah.
Very good. And you also, I met you at a trade show, so you attend other trade shows. Give me some of a list in case people are out there traveling, going to events. Where would they find you?
So on a yearly basis, for many years, we are doing both Passive House trade shows, the largest trade shows of the industry, FIESCON. That's going to be this fall in Houston, Texas, and also the previously in APHN, North American Passive House Network, now known as Passive House Network. And that's going to be in Denver And that is, I think it's going to be end of September or early October. I'm not sure. I'm sorry, I've got a blank memory. We also do NISI trade shows, Boston Energy. We are probably be also in I say probably at NISI, Building Energy, New York City. Also, what else we do? We go often in Connecticut. We did participate many times with Connecticut Passive House events, Massachusetts Passive House annual event. We did many times Passive House Maine events. Also, you and I, we saw each other at Maine Indoor Quality Conference, if I remember right, Building Performance Association events also, and some other events that are unis, twosies, not necessarily yearly events, but that's pretty much the trade shows we do.
I'll also put your LinkedIn link because I know you have a lot of good commentary and feedback on a variety of topics in the building performance and the HVAC industry. So he's a good person to network with. I encourage other people who are on LinkedIn to connect with Alex.
Thank you.
Thank you today for coming on the podcast. Really appreciate your time. I hope we generate some interest in your product and get some conversations going for you.
Well, let me thank you from the bottom of my heart. It was great having the chance to talk to you and to your audience. And I hope that we'll be able to help some people out there, because each time we sell a machine, it's either a person, a couple, or even better, a family that not only gets more comfortable, but more importantly, healthier.
Healthier, absolutely.
And noble cause, which is ours.
Thank you, Alex.
Thank you, Bill.
Thanks again for taking the time to listen to the Building HVAC Science podcast. There's other great trade-related resources and influencers out there, including the HVACR School, HVAC Shop Talk, Stephen Reardon, HVAC Reefer Guy, Tool Pros, Service Business Mastery, Quality HVAC, HVAC Overtime, HVACR Videos, HomeDiagnosis.tv, AC Service Tech, MeasureQuick, HVAC Chicks, and the Misfits of HVAC. I also host the Res Talk podcast, where you can learn more about the world of home energy ratings and peripheral topics. If you like what you've heard today, smash the like button. Well, you could just give us a subscription. That would be equivalent to that. If you're interested in corresponding with me in the Building HVAC Science podcast, please email marketing@truetechtools.com. In full disclosure, I'm a co-owner of TrueTech, and the opinions voiced here are those of my guests or myself, depending on who's speaking, of course. And if you're in the market for tools or test instruments mentioned in our podcast, take a look at truetechtools.com and use the offer code HVACBS for a nice discount. I want to thank you for listening to and hopefully following us on the Building HVAC Science podcast, and we'll do our best to keep you informed with interesting guests like Alex DeGagne. Take care, everyone.